So we spent a couple days on e to the x and log x. E to the x and log x are examples of inverses, okay? Inverse functions. They undo each other. X squared and the square root of x, another example of inverses. The key to inverses, and we are going to just examine inverses in general, just like in general, the relationship of inverses, but more importantly, or more particularly, since this is a calculus class, we're going to explore the tangent slopes of inverses and how they relate to one another, okay? And for inverses to occur, say f and g to be inverses, you need to undo what the other one does. So if I have f of x, and I want to just get x out, if I take g of f of x, I better just get x. This occurs with e to the x log x as an example. If f of x was e to the x and g of x was log x, for these to be inverses, if I did f of g of x, I better just get x. Well, that's g of x plugged in to x in f of x, so this would be e to the log x. We've talked before about how that's x. If we did g of f of x, we would plug f of x in for x where x is on g. This would be log of e to the x, and we said that's just x, okay? And that's great. But let's look in more general terms. Let's erase that x squared. Let's just pretend this is just some function f of x. And let's say this function's got the point a, b somewhere. Okay? So f of a is equal to b. Or f's got the point a, b. Well, if I plugged in, say, a here, okay, so I have like g of f of a. That means I'm going to have a outside of it. So I'm telling you f of a is b. Well, that means g of b has to equal a. Took f of a, replaced it with b. G of b has to equal a. What that means is that an inverse function is going to have the flip-flop points of the original function. This is why things get reflected over the y equals x-axis. When we talk about, the graphs of an inverse, we say, oh, it's reflected over the y equals x-axis. Why is that? It's like, well, our x goes to our y is going to have to go back to our x. Our y is going to end up equaling our x, and the flip-flopping occurs. So BA, would be around there. And you would see this kind of graph of G, the inverse to F, where the points are flip-flopped. And this is important. Inverses have flip-flopped points. We can do that really quick with e to the x and log x. Let's look at e to the x. F of 1 is e. So f's got the point 1e. Well, g of x we know is log x. G of e is 1. Yeah, the log of e is just 1. So g's got the point e1. Okay, but now let's look at the relationship of tangent slopes. Are they related? Are they not related? What can we see about, say, the tangent slope to f at AB and its relationship to this tangent slope of g at the point BA. I'm just going to go ahead and say that this slope is C. Okay? That's slope C. I'm just going to say. Like, my goal is to find what is this tangent slope. Looks like it ends up being 1 over C. And you are exactly correct. Now, I'll show you exactly why in a second. But let's think about it. If this is dy dx for an x and a y, well, this is the y, then the x. It's flip-flopped. So dy dx becomes dx over dy. It ends up being a reciprocal. That's one way to think about why they're reciprocals of each other. Another way is creating what we'll call an inverse derivative formula, which we won't really use, but we could. I'll show you how you could use it if you wanted to. Okay, so just a quick reminder, and what we're trying to find is this g prime at B. Okay, and it's like, all right, well, g's got the point BA. What is its slope? And just for information, we knew f has the point AB, and the slope was C. Okay, trying to find the slope of G at this point B. We think it's 1 over C. Let's confirm it this way. I'm going to create a formula for G prime by taking the derivative of, like, the definition of what it means to be an inverse, f of g of x equals x. Now, I can do this because I know the chain rule. We got an O, we got an I, take the derivative of the outside, multiply by the derivative of the inside, get f prime times g prime of x. So, f prime of g of x times g prime of x is the derivative of the left side. I can't neglect the right side. Its derivative is 1. So I got an equals 1. And I want a formula for the derivative of g. So I could plug in b. Well, there's g prime of x. I could just divide both sides by f prime of g of x. And I get g prime of x equals 1 over f prime of g of x. Okay, if I want to find g prime of b, it turns out it's just 1 over f prime of g of b. Well, watch how this works out. G of b is a. F's got the point AB, G's got the point BA. F prime of A is what I told you was C, so this ends up being 1 over C. So just like we saw, dy dx ends up dx over dy. It's just the reciprocal. 1 over dx over dy gives us dy dx for G. Tricky to kind of understand, but what we will be doing is not all of this stuff. We won't even be using this. So this is what we would consider the inverse derivative formula. So tangent slopes of G, this is considered the formula. But really what I want us to focus on and to use is this understanding of functions, inverses, and tangent slopes. This is what I'll call the inverse derivative table. We will be asked to find tangent slopes of G. We will be given information of F. As long as we understand how F and G have flip-flop points and that their slopes at those flip-flop points are reciprocals, this is not a tough lesson. Okay, let me show you what I mean by, like, understanding this to answer some questions that we are going to be asked to answer. Okay, here's our first question. F and G are inverses. Find G prime of 3. So I'm trying to find the tangent slope to G at 3. And I'm given the function for F. Okay. Then just start creating my table. Is that okay? Well, I'm trying to find G prime at 3. So that. But that's all I know about G right now. So I'm trying to find its slope at 3. But I know about F. Well, understanding the flip-flop points with F and G, if I'm trying to find G prime at 3, it would be the same as finding F prime at whatever this value is when its Y value is 3. So knowing that G's got this point 3 something, I know F's going to have the flip-flop point something 3. Now, in most of these situations, you will be given information to lead you to this point that you're trying to find. But in this case, I'm not. It's no big deal. When my Y is 3, what is X? I can solve for X very easily. Square both sides. Add 3 divided by 2, I get X equals 6. Okay. F of 6 gives me 3. That means G's got the point 36. This actually isn't important, the fact that G has the point 36. Sometimes I'm asking you for it, and that's great, but it's actually not important. Because what is important is the slope of F at 6, 3. Its reciprocal will be the slope of G at 3, 6. So all we need to do is find the slope of F at 6. Take the reciprocal of it, I'll know the slope of G at 3. So here we go. F prime, we got an O and an I. The 1/2 is the O, the 2x minus 3 is the I. I need to remember my derivative rules and use them. And I get 1/2 2x minus 3 to the negative 1/2 times 2. That can be simplified to be 1 over root 2x minus 3. Find F prime at 6. F prime of 6 is 1 over root 12 minus 3, which is 9. I get 1/3. If the slope of F at 6 is 1/3, the slope to G at 3 is 3. This will always be true. I forgot to go back actually and just like show you with our first example, e to the x and log x. Like, remember the tangent slope generator for e to the x is e to the x. Let's create the table here. So f prime of 1 is e. My table says I should get 1 over e for the derivative of g at e. Well, g prime of x is 1 over x. So if I plugged in e into g prime of x, I got 1 over e. See how the table works? We'll do the same thing kind of with inverse trig derivatives eventually. Okay, cool. So that's all we're doing here for most of our problems. Now, let's look at this guy. Let's go ahead and set up our table and see what information we need to find about f. Okay, ready, set, go. Trying to find g prime of 3. careful, g prime of 3, when the x of g is 3. That's my start. Okay? Then I say, all right, well, inverses, that 3 is over there. What you will see for most of these problems is either something that you could find easily or something that you will be able to find easily, or they will be giving you just in the problem a point or a couple points to help you out. In this situation, if I set 4x cubed minus x equals to 3, not an easy equation to solve. You could solve it by just looking at it. That's probably the easiest way. But instead, what you are going to find is that there will be information given to you. You will see this in your homework. I will be giving you points that you will be using. Sometimes the points are not all used. Sometimes they are. But this is showing me that when x is 1, y is 3. 4 minus 1 is 3. If I know the slope to f at 1, I'll know the slope to g at 3. F prime, 12x squared minus 1. F prime of 1 is 11. G prime of 3 is 1 over 11. Now you are asked to write an equation of a line tangent to g at x equals 3. You're going to use this information for your equation of your tangent line. You have everything you need. You have an x coordinate, you have the y coordinate, you have the slope of the tangent. This would be the correct equation of the tangent line. Okay, let's see if you guys can do the whole thing. Next one. First off, before we get into this is f inverse. This is not f to the negative first, it's f inverse. If you see f inverse, you treat it like it's g of x. We got to understand that f of f inverse is still follows. This is no different than g. So don't get stuck on always using g. F and f inverse will have the same situation. G is the inverse of f. Okay, so understanding that, I want you to find f inverse prime at 2. So, and I will tell you, f of 1 is 2. This will just be given to you. So write that down. Check your answer with the neighbor. Two is the x coordinate of g that we're trying to find. We're trying to find g prime of 2. Okay. The answer is 1/4. We just need f prime of 1. If you know f prime of 1, you know g prime of 2. All right, it'll take some time for us to get used to this. This is new, and I feel like since it's after lunch, Our brains are not functioning as efficiently as they usually are. Ready? We go. Okay, F inverse has got 2 something. I know F of 1 is 2. I was told that. You're trying to find F inverse prime at 2. Well, if I know F prime of 1, so 1 being the important point, which will give us the derivative of F inverse at 2. I need to find F prime. F prime is 3x squared plus 1. F prime of 1 is 4. Since this is 4, the derivative of F at 1 is 4. The derivative of F inverse at 2 is 1/4. Okay? We'll get the hang of this. Sometimes doing these problems help us get the hang of this, because you will find when you're doing some quizzes, when you're taking the AP test, that not always will you give the equation. Because actually these are easier. You have all the information you need to find the derivative of g at 2. See if you can find it. This helps sure up our table creation and understanding. G prime of 2. Start with that. Sorry. Okay, that's where you start. X, Y. X, Y. Yes. F's got the point 5.2. Yeah. G's got the point 2.5. Yeah. Great. And flip-flop. Yeah. If I know the derivative of F at 5, I will know the derivative of G at 2. Just the reciprocal. Just flip-flop.
Oh, it's right there.
It's right there. Yes. Answer's -2. Sometimes you just got to walk through it, right? I'm trying to find G prime of 2. This is where I start. Start with that. Okay, F, then, it'll be important to find the slope of F when it has a y-coordinate of 2. Well, F of 5 is 2, so F's got the point 5.2. The slope of F at 5.2 is -0.5. The slope of G at 2.5 will be -2. Okay. Do the next one. What is G of 3 and G prime of 3? You start with G. I didn't give you enough information. I messed up. Change this to 4.3. Sorry. Start with G. I'm trying to find G of 3. G prime of 3. F. I know information of F at the y-coordinate of 3. Well, that's at 4.3. Its slope at 4 is 9. Not 7. Since the slope is 9, the slope of G at 3 is 1/9. G of 3 is 4. G prime of 3 is 1/9. Okay? Now, you will see tables of information given to you. You'll need to find the correct point. You'll need to find the correct slope. Take the reciprocal of the correct slope. I'm trying to find f inverse prime of 3. You have all the information you need. So don't use f and g. In this case, it might be easier if you use f and f inverse. I'm trying to find f inverse prime at 3, not at 5. Yep, that's the start. The goal is to find f inverse prime at 3. That's what we start with. Let's see if we can get this. Yep. 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 It's not that. Very good. Nope. Nope. Yes. You're trying to find f inverse prime at 3. G's got to have the point 3. F is not. You're not trying to find f prime at 3. You're trying to find f inverse prime at 3. It's not 1/4. It is -1/2. F inverse at 3. I want 3 there. You're telling me f inverse at 5. You're going to have to change this because you're changing this. You're trying to find f inverse prime at 3. That's where you start. Make sure we see where we start. We start there. Trying to find an f inverse prime at 3. Well, that means I'm looking for a point on f that has a y-coordinate of 3. F of 5 is 3. That means f inverse has the point 3, 5. The slope at the point 5, 3 for f is -2. That means this slope is -1/2. All right, let's keep going. Let's see if we can all get this one here. F inverse prime of 2. You're given a bunch of information. You're only going to use some of it, just like in the table. Two for f inverse is what I want. I want f inverse prime at 2. Yes. You're saying that x is 9 and y is 2. And it looks like y is 9 and x is 2. F inverse 2. F has a point with a y-coordinate of 2. When x is 6, y is 2 on the graph of f. That means if I know the slope to f at 6, which is -3. I'll have the slope to f inverse at 2. Do the next one. Then we're going to switch gears. Ready? If you've done enough of these, you figure it out pretty quickly. F's got the point 6.3. The slope at 6 is -2. G's got the point 3.6. The slope is -0.5. I feel like we've already done that. All right, moving on. Unfortunately, and I apologize for this, there are other ways to do these. However, I wouldn't recommend it. We need to know the tangent slope generators for inverse trig functions. Arc sine can be written as sine inverse, arc cosine cos inverse, arctangent tan inverse. These are the inverse functions for sine, cosine, tangent. Now, for these, there are tangent slope generators, specific ones. We could use kind of the table understanding of inverses and slopes and points with inverse trig functions. And I'll show you how we can do it. You can pick the way that you'd like. You can either do it the table method or just use the tangent slope generating equation, which you'll have to memorize, 1 over root 1 minus x squared. That's the tangent slope generator for arc sine. Arc cosine, -1 over root 1 minus x squared. Arc tangent, 1 over 1 plus x squared. After next unit, I can tell you why those tangent slope generators are what they are. But for right now, let's just take my word for it. Okay? I'll give you these for your quiz next class, but for your test, I won't give them to you. And you'll have a couple questions where you can use them on your test. If there's a composition, let's just see what it would look like using the chain rule with arc sine parentheses now being the outside. This is a new kind of outside. So remember, like, the parentheses are usually where like x goes. So like wherever x was gets replaced by parentheses. So the derivative would be 1 over root 1 minus not x squared, but parentheses squared. The derivative of the inside is 2. This derivative, y prime dy dx, would be 1 over root 1 minus 2x squared times 2. Or 2 over root 1 minus 2x times 2x, 4x squared. Do not square root the 1, do not square root the 4x squared. There's a subtraction symbol in between them. You can't simplify that. All right, you guys try this one out. It's very similar. So it's 1 over 1 plus x squared is the derivative of inverse tangent x. So I had 1 over 1 plus 3x squared, which is 9x squared times 3. 3 over 1 plus 9x squared. Don't try to simplify the 3 and the 9. You can't because of the addition. You just leave it like that. The next couple I'm going to come back and do. Actually, this one I'm going to come back and do, but this one I'm going to finish off with. I'm going to continue to do the notes into Genius Hour to finish off the notes if you want to stay. If you have off campus. If you have first period CTE class, make sure you go to that. Let's talk about this. Okay? Find f prime at root 3 over 2. I'll show you how you can do this 2 different ways. First way, which I actually consider the easier way, is using the inverse derivative formula. 1 over root 1 minus x squared. Now, this is easy if you have it memorized correctly. If you don't have this memorized correctly, this is not easy. If you want to try to find f prime of root 3 over 2, 1 over root 1 minus root 3 over 2 squared. We have a little bit of simplification that we need to do. Root 3 over 2 squared. Root 3 over 2 times root 3 over 2. 3 over 4. 1 minus 3/4. That's 4/4 minus 3/4. That's 1/4. Square root of 1/4. Square root of 1 over square root of 4. 1/2. 2. Final answer to this is 2. I think that's easy. Now, what's the alternate approach? Let's say we didn't know the inverse derivative formula. You could say, well, it's an inverse, and I'm trying to find it at root 3 over 2. Its inverse, almost consider this like g. Its inverse f of x sine x. So the inverse of this, I don't want to say this is f, just its inverse is sine x. Well, let's think about sine x. Do we know an angle where sine x gives me root 3 over 2? Don't leave. Nobody's leaving until somebody gives me an angle, which sine x equals root 3 over 2. Pi over 3, thank you. Hold on. If I know the slope to sine x at pi over 3, I know the slope to sine inverse at root 3 over 2. What is the tangent slope generator of sine? Cosine. What's the cosine of pi over 3? 1/2. Oh my goodness. There's 2. So you could have done it that way as well. I wouldn't recommend it. You may leave now. I'm going to continue with the notes. This one, this previous one, is more a fancy simplification problem. When you take the derivative, it simplifies nicely. Let me show you. Okay, so watch when you take the derivative of this crazy looking thing, what happens after you simplify? We have a product, so let's use the product rule. You got the derivative of the first times the second, plus the derivative of the second. You'll eventually have these memorized, I hope. Negative 1 over root 1 minus x squared times the first. Minus the derivative of 1 root 1 minus x squared. This is a chain. We had a derivative of root earlier that included a chain. So derivative of the outside times the derivative of the inside. And let's see what that looks like. I got a 1/2 1 minus x squared to the negative 1/2 times negative 2x. So the 1/2 cancels with the 2. A negative and that negative x turn into a positive. And let's see what I got. Arc cos x minus x over root 1 minus x squared plus x over root 1 minus x squared. This minus x over root 1 minus x squared, that's positive. They cancel. I just get arc cos x. That would be y prime. So that's just a interesting, take the derivative, simplify a little bit, you'll notice some things cancel. Most of the problems we will be doing will just be like derivative of this inverse trig function at a value. So find the tangent slope to arctangent at arctangent of 4x at x equals 1/4. Use the chain rule to find the tangent slope generator. One over 1 plus 4x quantity squared times 4. If you want to simplify this now, you can. However, you're trying to find this at 1/4. I'm going to plug in the 1/4 right away because the 1/4 times the 4 is just 1. So that just becomes 1 squared. So this is just 4 over 2, which is just 2. Okay. We'll finish with one more. I'm going to change this question. Get rid of that x. I'm going to ask you to find thinking of the equation of the tangent line to arctangent at pi over 4, but it actually doesn't work out nicely. So don't worry about that one. And don't even worry about this one. You'll have enough of example problems in your homework of what I would be expecting you to do with these trig functions, which is just pretty much a trig function, composition, at an x value. All right, thanks.